Hi class, Professor Smith here. I'm super excited to create a video on using the midpoint rule to approximate a definite integral. In this example, we're asked to use the midpoint rule with n equal to 4 subintervals of equal length to approximate the following integral. So we have the integral from 1 to 4 of 1/3 x squared minus 6 dx. Carry your intermediate computation to at least 6 decimal places and round your final answer to 4 decimal places. So we'll first start off by sketching the graph so we can see what is represented by this definite integral. So let's take a look at the function f of x equal to 1/3 x squared minus 6, and we want to take a look at it on the interval from 1 to 4. We know that when we have a quadratic function, because of this x squared, we know it's going to be a parabola. The leading coefficient of x squared is 1/3, which is positive, so it's going to open upward. Since there's no linear term, no x term, we know that the vertex is going to occur when we let the squared term equal 0. So if we let x equal 0, then we get minus 6 for the functional value. So f of 0 is equal to minus 6, and that lets us know that 0 minus 6 is the vertex. Don't fear, I am going to go out to Desmos so we can represent this, because we're going to use technology to do some of this computation, just so that you can really see the beauty behind what we're doing when we're using this rectangle method. So here's 0 minus 6, the vertex. It's going to open up. And then let's go ahead and evaluate it at 1 and 4. And so when we do f of 1, we get 1 squared and then times 1/3. That's going to give us 1/3 minus 6. And then we can rewrite the 6 with a common denominator of 3. And so we have 1 minus 1/3 minus 18/3, which just gives us a minus 17/3. So a little bit less than 6 at x equal to 1. And then let's go ahead and evaluate our expression at 4, the end of our interval. And so when we compute f of 4, let's go ahead and give ourselves a little more real estate. We have 1/3 4 squared, but 4 squared is 16. So that's going to be 1/3 of 16, or 16/3 minus 6. But that's just the same as 16/3 minus 18/3 from the last example, and we get minus 2/3. So at 4, where it's almost going to touch the x-axis, but not quite. So our graph is going to look something like so. And the definite integral, let me make that a little bit better there. So our definite integral is represented by this shaded region. So it's everything below the x-axis to the curve from x equal to 1 to x equal to 4. And so they're asking us to break this up into 4 subdivisions, and so we can do that by taking 4 minus 1 and dividing by 4. And that gives us 3/4, which is equal to 0.75. And I'll call that delta x, little increments of x that we're chunking off or partitioning that interval from 1 to 4. And so if I add 0.75 to 1, that'll give me 1.75. So let's go ahead and draw this on the next page, maybe a little bit larger. Now that we have a little more real estate, let's go ahead and add that increment of delta x of 0.75 to 1 and keep adding 0.75. So the first we'll get 1.75. And then if you take 75 cents and 75 cents, if you add another 0.75, that'll give you $1.50. And $1.50 and 1 gives you $2.50. Now if you want, you can use a calculator. And then if we add another 0.75, $2.50 plus 75, that'll give us $3.25. And then if you did 0.75 again, that'll take you to the 4. So you know we've done it right. All right, so this one here will be 3.25. And so what they've asked us to do is they've asked us to partition it and do 4 rectangles, but they want the rectangle based on the midpoint. So let's go ahead and find the midpoint. So I'll color those in these little seafoam dots. So halfway between 1 and 1.75, then halfway between 1.75 and 250, halfway between 2.5 and 3.25, and then and then halfway between 3.25 and 4. So that'll give us our 4 midpoints. Once we find that midpoint, what we're going to do is we're going to say, well, look, I want to take a look at the rectangle that has a height based on that midpoint. And so let's go out to the function to find that height. So again, I'll use that same teal color. And then I'm going to draw a rectangle with that height, or depth in this case, since it's below the x-axis. And then I'll do the same for the second midpoint. So I'm going to go from the midpoint to the function, and then I want it to have that depth on that functional value. And that rectangle is the one that we're going to find the area of. Do that for each one of those subintervals. So let's organize this information by taking a look at a table, and then we're going to go out and use technology to capture this a little bit better and more efficiently. I've captured my table starting off with the index of I, going from 1 to 4 because there's 4 different rectangles. And then let's go ahead and start off by finding our midpoint. So I'll label this one M sub I. And later on when I use technology, you'll understand why I add in this subscript of I. It'll make the computation a little bit easier. So in order to find the first midpoint, we're going to take 1 and 1.75 and divide it by 2. Thought I'd give myself a little more real estate. All right, there we go. So 1 plus 1.75 divided by 2. And then the next one, for the second one, we're going to take 1.75 and then 2.5 divided by 2. And then for the third, we're going to take 2.5 plus 3.25 divided by 2. And then what's going to happen was we're going to notice a pattern. We found that that little delta x was the distance between the first value of our interval to 0.75 over. Well, it turns out that distance of 0.75 is also the same distance between each of the midpoints. So in other words, we can do this long computation and do it for each one, but it's easier after you find the first midpoint to just keep adding 0.75. So let's go ahead and do that computation. So I'm going to do that real quick. You can use a calculator to do it. 1.375. You get 4.25. Divide 4.25 by 2. And you get 2.125. And it turns out the distance between those two values is 0.75. So let's go ahead and add 0.75 again, and we get 2.8. 5 and 2 is 7. 5. And then for our last one, we're going to add 0.75 again, and you get 3.625. All right, so now we have our midpoints, and let's go out to another resource, which is Desmos, in order to finish out our problem. So now I'm out on the website, desmos.com, and I also have a link for this on our website for Canvas. And you'll see that there's an option of opening the graphing calculator. If you scroll down too, you'll see that there's other math tools as well. So I'm going to go ahead and either you can select the icon that says graphing, or up here the little box that says open graphing calculator. On the plus sign, you'll see that it's asking us to add an item. So I'll select the plus sign at the top left. And one of the options is a table. So I'll select table. I'm going to turn the first value that they have as the header of the table. I'm going to rewrite that as I, keeping track of each one of the intervals that we had. So we had 1, and then I'll just hit the return key and type 2, 3, and 4 underneath the I icon. And then next I'm going to write down the midpoints, and I'm going to use the letter M for midpoint, and then I want to create a subscript. And so to create a subscript, I can either use the keyboard that's available on Desmos, which is in the bottom left corner, and it says show keyboard when you hover your mouse over the keyboard icon. You select the keyboard icon, and then there's the letters A, B, C in caps also on the left. And then you'll see right to the right of the 1, 2, 3, now that you've switched to the ABC keyboard, you'll see an A sub B. That allows you to create a subscript. And so the minute I select that A sub B, then it turns out I have a little subscript underneath the M. So it's basically to the bottom right of M. And then I'll go ahead and put in the letter I. You can also create a subscript by hiding the keyboard. We don't have to hide the keyboard, but you don't need the keyboard. And so another way to create the subscript is I'm going to erase it and start all over. I'll type M, and then I'm going to hit the Shift key and then the underscore key, or the minus sign, which is next to 0 on the top of your keyboard. So if I hit Shift minus, that also creates an opportunity to write a subscript. So M sub I. All right, and so then let's go ahead and put in our midpoint. So we had 1.375, and then the second one was 2.125, and then the next one was 2.875, and then the next one is 3.625. I keep putting commas instead of periods. Sorry about that. All right, let's make this just a little bit bigger so you can see. And so you'll see over on the right, so I'll slide this over a little bit, you'll see the dots there representing those midpoints. All right, now what I want to do is I want to find the height of each one of those bars. So in order to do that, I need to put in the function. So I'm going to go where it says 2 underneath the table, and I'm going to type in my function. And I'm going to call it f. And I'm going to put f of x equal to 1/3 x squared. And to create that squared, I hit Shift 6 in order to get the exponent. But you can also use the keyboard and hit the a squared key. So if you hit x and then select the a squared key, that'll give you the exponent as well. And then minus 6. All right. And then the next thing I'll do is I will create the y values, and this is where the technology really is sweet. I'm going to go back to my table, and then I'm going to type in f, and this time I'm going to compute the functional value at the midpoint because I want to know that depth of each rectangle. So I'm going to put f sub m, and then to get that subscript, Shift underscore for I. And isn't that sweet? It automatically fills in all the values. I was trying to put a closed parentheses, but I was putting the closed parentheses around the subscript, so I really don't need it. It did it for me. So I have all those values for each one. Now, it doesn't look like it because you see these dots. You have the green dots and the purple dots. So to really get a better idea, let's go ahead and create ordered pairs. So I'm going to put parentheses x, Shift underscore I, and then I'm going to tab to get that cursor from being in the subscript, comma, y, Shift underscore I. And now I'm going to, it's saying all. Oh, no, I don't want to do that. Oh, no, I know what happened. I know what's wrong. My fault here. Let's get rid of this x equal to 1 business. We're going to put m sub I, because that's the first one, and then f sub m sub I. There we go. Isn't that cool? And so it lists all the ordered pairs, and you'll see that they're blue, that little blue icon. And if you look at the graph, let me move this up just a little bit, you'll see the graph has those blue dots. So just so it's not confusing, I'm going to go back up to the table, and I'm going to get rid of the green and purple dots representing m sub I and f sub m sub I. So now we just see there what we have. Now, if you want to see the rectangles, you don't need to do that for this problem. If you want to see the rectangles represented, you can do that. And so let me show you how you would represent those rectangles. So I want the rectangle to have go from 0 to the first midpoint, f sub m1, and the first midpoint was 1.375. Or you could actually even put in the y value here so it's already there for you. Yeah, you could do that. So I'm going to go 0, and then I want to hit less than or equal to. So you can use the keyboard, and there's the less than or equal to symbol. Or, oops, I hit the wrong button. Or you can use the keyboard on your computer, and you can just hit the shift key, which is above the comma. So if you hit shift less than or shift comma, and then hit equals right after, it'll change it to less than or equal to. Is that just too cool? So you can just do that as well. So you can either use the keyboard or you can not use the keyboard. All right, so we're going to go from the lower point of the rectangle is from the depth. So let me fix that. So not 0. I'm going to go from f of 1.375 is less than the y values. That's the depth of my rectangle. And then go up to 0. And I'm going to do that. And so you can see I have that rectangle. And then I'm going to restrict that rectangle so it's just on that first interval. I want it to go from 1 to 1.75. So in order to restrict that black rectangle that you see there so it doesn't go all the way across, I'm going to hit braces. And then I'm going to make sure I want my x values to go from 1 to 1.75. So 1 less than or equal to, and I'm going to just use the keyboard for this particular case, less than or equal to x, less than or equal to 1.75. And so now you'll see when I hide the keyboard, there's that little rectangle that has the depth of f of 1.375, which is negative 5.37, and it has that width from 1 to 1.75. Let's go ahead and copy that so I don't have to retype it again. It's funny, the mouse likes to work from right to left. It won't work as well from left to right. Interesting. All right, so let's hit Command C if you're on a Mac to copy it, or Control C if you're on a PC, and then paste. All right, so now what I'm going to do is I'm going to go from the second midpoint, and the second midpoint is 2.125. To 0. And then now, instead of going from 1 to 1.75, I'm going to go from 1.75 to 2.5. And then you see the blue rectangle next to it there. All right? And then we'll go ahead and paste again. And now we're going to go to the third midpoint. So if you select that 4-element list, it'll show you the third midpoint, 2.8725. Or you could just put in these values. Yeah, you really could put in those values. Usually they're not as pretty as these. Sometimes they're 6 decimal places. And so it's easier for me to just put in the midpoints, which usually are only 1 to 3 decimal places. All right, so let's go ahead and put in f of 2.8725 up to 0. But now we're going to go from 2.5, adding 0.75 again, to 3.25. And now we see the green rectangle. And then let's add the fourth one. And so now we're going to do f of the third midpoint, because remember the depth of the rectangle is supposed to be the depth of that at that midpoint. So we'll go f of 3.625 less than or equal to y less than or equal to 0. I thought I was supposed to copy it. Did I not copy it? I didn't copy it. I think I'm getting a little bit tired. Also, there's braces in here. So if you want to use the Desmos keyboard, you can use the Desmos keyboard to put in the braces. And now I'm going to go from 3.25 to the endpoint of 4. All right, and then we'll go ahead and hide our keyboard. And there's the fourth rectangle. So we're using those 4 rectangles with the midpoint values in order to find the area. Now you're saying, well, why did you create that table with the eyes? Well, it turns out each one of these rectangles have a base of 0.75. So we have 0.75 times the first height. That'll give you that area. 0.75 times the second, 0.75 times the third, 0.75 times the fourth. Well, it turns out you could factor out the 0.75. And so what we could do is we could just say 0.75, and then we're going to do it times the total, Shift 8, total, F of m sub I. All right, so there we get it. The definite integral has the value represented by the area, or maybe the negative area, between the x-axis and the functional value by these four rectangles added together, giving us a negative 11.46875. So let's go out to Alex and check our work. I'm going to copy this. I think it's at 4 decimal places. And then let's go back out to Alex. And then paste. And round to 4 decimal places. 1, 2, 3, 4, 5. So we don't need that digit. And so 7 is 5 or more. So I'm going to raise the previous digit by 1 and truncate the 7. So that 8 will turn into a 9. So let's check our work. Hot diggity dog, and we got it correct. Let's summarize the steps needed in order to use the midpoint rule to approximate a definite integral. I have here 4 steps, but one of them you don't necessarily have to do. The first one is sketch the curve over the interval AB and let f of x equal the expression in the integrand in order to graph that curve. And that's the step you could omit, but I think it's great to do. And so here I have the sketch of the graph using Desmos. That's not necessary. Step 2 is important, and that's to partition the interval. And the way you do that is you find delta x. And so you add delta x to the beginning endpoint to find subsequent subintervals. And to find delta x, you just take the right endpoint, b, minus the left endpoint, a, and then divide it by the number of partitions. In our case, 4 minus 1 divided by 4. And we got delta x equal to 0.34, 0.75 or 3/4. And then the next step is we want to find the midpoints. And we find the midpoint using the midpoint formula. And then to get the subsequent midpoints, just add delta x to each midpoint. And the formula for the midpoint is by adding the two values, x1 and x2, and dividing by 2. And that's what we did. We added 1 and 1.75 and divided it by 2. Then next, we have finding the area. To find the area, you have to evaluate f of x at each one of the midpoints, m sub I, and then sum them up. We also make sure that we multiply by delta x. The
function evaluated at each of the midpoints gives us the height.
Then multiply by delta x, which is the base. And when you multiply the height times the base, that gives you the area of the rectangle. Then you can sum up all of those areas, and that will give you the total area. However, since delta x is a constant, I recommend that you sum up all the heights and then multiply by that constant delta x. So I hope this video on using the midpoint rule to approximate a definite integral has been helpful.